Hello everyone. I've gotten a lot done this week. I'm going to cover what I was floundering on earlier and how I fixed it, as well as a bunch of other stuff that I got working over the past week. It's been, pretty hectic. So, without further ado, let's hop in. So when I had to rewatch my video last week to see where I left off. I didn't stream on Wednesday because I just didn't know what I was doing. So I figured I'd read some stuff and learn to see how I should be doing things. So I read up on delegates and all the other stuff that I needed to learn about, mainly due to issues I was having with the WebSockets connection, where it would work fine. And then the way I was capturing the this pointer with lambdas, it's captured, but it's not keeping a reference to it. So when my game shut down, every time my UE would basically crash. So that's not good. That should not happen. So I read up a bit on delegates and how to actually bind things properly, as well as how to safely remove references to things. So where I was, I think that was in... Oh, and also I got rid of the entire WebSocket class because it was just causing extra levels of abstraction that I just didn't need, and I just implemented it directly into the game instance. So if we look at the game instance now, it's communicating directly with the menu via the menu interface, and then when it calls connect from the menu, validates the address, and then it sets up using add U object. So this will allow me to bind the onConnected as a delegate for this U object, which is this game instance. There's only one of, as well as return a handle. So these handles are super important because you want to remove them, and you don't want them kind of dangling once the connection's done or the class is destroyed. So that gets done here in shutdown, where we make sure we have a socket, and then we remove those handles. So if we need to recreate a new one, we just pop it back in and replace all those references again, and then go on the same way. I also got networking pretty much working, except to the point where you can queue for a game. So now the game instance can process the on messages and sent messages and all that other good stuff that we're going to need. So that's working pretty well. It took me quite a bit to figure out the JSON interface stuff because, it's pretty nasty, and I'll show that in a second. But so the game instance now can handle the connections, the messaging, and feeling pretty good about that. So we should be good to move on. Is there anything else? Selecting characters is going to come again from the menu. So when you select a character, it allocates or sets the character ID as well as the slot number, messages that to the server, as well as selecting abilities. So when you lock in the character, it'll take the abilities that you selected and then send that off. Right now it's all hard-coded in the menu, but that's another story. And then entering queue, pretty straightforward. Make sure we're connected, make sure we have a group ID, and then pop ourselves into queue. So that's what messaging looks like. It's nice and short and sweet, nothing too complicated there. The complicated bits are in network messaging. So now that I actually know how to properly create classes in UE4 outside of the editor, this went a lot smoother. I also was able to get enums working and structs and all that other good stuff that I'm going to need all over the place. So the U messaging is a U object, but every method is a static method, so I can just call them whenever. I don't need to create the entire object if I don't want to. So that's working well. These are the interfaces, or the methods for this particular messaging class, and if we look at them, it gets a little nasty. So how does this all work? The read message type is probably the most complex because we need to take in a string. We need to figure out just one field, the type field, which is on line 19 here. So once we figure out the type field, we then will know how to decode it properly with the other methods. But the problem is we don't know what it is, so we need to get the data field, which is the rest of the message for what it was supposed to be. And then we have to do something kind of janky, and I don't know if this is the best way to do this. So usually what you would do in C++ or anything else is you would have a union field where it could be one of many objects. I don't know how that all works in Unreal or if it works at all. So I just, for now, take that field, take it as a series of values, then serialize it back into a string, reassign it to the struct's D field, which is just an F string, and then return this F network message. So it's a little bit roundabout in how it works, but I mean, this is only happening, there's not many messages in this game, so I'm not too worried about like performance or anything like that. The client, like the client side stuff compared to server is just, it's so much more relaxing because I can be like, hey, whatever, it's fine. It's not a big deal if there's a little bit of a performance hit. But server stuff, I have to really be much more, take more care. Although that's not entirely true. Materials and textures and all the other objects on the map I'll need to be aware of, and I'll cover some of the performance stuff that I had to do for that once we look at the map. So back to JSON messaging. Right. So we have our read groups and read game messages. And again, so we take that message back with a D, and then we pass that string into these messages to further, not destructure, what is the word? Deserialize. To deserialize the object into whatever object it is. So there's these converters, which helps. So if we look at like a group message, we can just define a ustruct, make sure it has generated body, and then all the U properties are set. Once that's all good, then you can just call that JSON object string to ustruct, and it'll automatically deserialize everything for us. So we don't have to do all these weird set number fields, which you can see here. This is for when we create the objects. So if we are doing the create message, we have to create the JSON object as a make shareable, which I don't really understand what that does, but it's making a shared pointer is all I know. I don't know exactly the inners of it. Oh yeah, so it says the following is an Unreal extension of the standard shared pointer. Okay, so it's just a shared pointer, so multiple classes can have access to it. Yeah, and then we do some weird static casting for our enum types, and then yeah, we just set the fields and fire it off to serialize message, which is what combines all that stuff together in a single message. And then we use the same technique I showed earlier of using a JSON writer to write and serialize the object, and then we return that as an F string. So pretty basic stuff, I guess. But again, it took me a while to figure all this kind of nasty stuff out, especially with it's like objects or arrays. Where's my object stuff? I think this is the one that took me the most time. I just could not wrap my head around how I was going to get it to work. Oh, the object stuff is actually easy because I could use JSON object converter. So we're good there. So that's messaging, group messages, nothing too crazy. You've seen all this, but in Go. So it's just the selected abilities, our group message. Game messages are going to get a little bit more complex, where we have much more data coming in, like modifier types, power-ups, team data, spawn data, all using integers. Again, we're trying to stay away from floats as much as possible so that it's much easier to work with. And yeah, that's covers the JSON stuff pretty much. So cool. Yeah, that's our networking. I still haven't gotten the pathing stuff in yet, as well as it actually spawning the level. But I do have the level generation working. So let's take a quick look at what it looks like. Oh, one more thing before that, I want to hop back into menu stuff. So before I was looking at how I was going to get these characters to show up inside of the menu, and I was going to use the screen capture 2D, which I did end up getting to work. So if we look at this, and again, sorry for the small font on the side. Does that work? It does. Cool. So this is the menu, game menu. You can see here now we have this rendered scene inside of our menu, which is awesome. What's really cool though is if you move this around in the world, it updates the screen capture. So what I'm going to do is I'm going to have an actor spawn all the characters, and then when you select the character, it'll rotate, it'll be in a circle, and it'll rotate this camera actor or screen capture actor around that the radius of it or the circumference of it to get a nice kind of slide in picture of the character when you select them from the menu. So yeah, that's working. All these buttons work now, so that I can actually enter Q. I don't really need to demonstrate it because it didn't do anything yet other than enter a Q, which isn't very exciting. But what else do we got? So that's the menu stuff. Level. So yeah, it took a little bit of work to move from the Go's version. I was thinking of doing an enum, but it was kind of a pain, so I just went with constants, integer values, so I don't have to do casting and stuff back and forth. But the kind of the hierarchy of this is that you have this battle level, and the battle level is it's not an abstract class, but most of the methods are going to be overridden by each individual level because they have the data that's necessary to generate the level. But there's a couple of things that are built into it in terms of like the static mesh components, as well as the materials, as well as the actual generation is done within this base class. So all the level needs to provide is that tile set, which we've seen many times before, as well as override the height, the width, and get tile, and that's it. So each level is going to be very basic of just providing those details. So it'll make it really easy to generate new levels. I just need to pop in this data and then off I go. Although I did see while I was debugging some of this, I found another project where they did something really neat where instead of doing it like this, they actually took a 32 by 32 bit image file and they color coded the pixels. So instead of reading it in as this 2D array of tiles, it would read it in as an image or a bitmap, and then each color or bit inside of the bitmap would determine how it would spawn the level, which I thought was really smart, and I kind of like it, and I kind of want to take it. But then I realized I have other I could do two images of the base level using that one image, and then any sort of power-ups or additional like fences that I have around the edges of walls and things. I could have another image where I could overlay those two and read both, but it's like you're not going to do this that much. There's probably going to be like 5 or 6 levels total. I think Alice Reactor only had like 4 or 5, so I don't imagine this is going to be the most time spent here. It'll be other places like abilities. So I think for now this will work. So if we want to actually see, actually I'm going to show the code first, then I'll demo. So battle level, how does it work? The battle level is going to be repurposed as going to create a blueprint which will parent this base class, and then you'll basically set that information. This information here, which is the wall meshes, materials, floors, floor materials, stealth, unwalkables, and fences, which I need to make this mesh myself. I haven't made that yet, but we are getting there. So battle level. So everything is, this all needs to be overridden. The only thing that's really implemented here is the create tile instance, make sure everything's configured, begin play, tick, that's all, doesn't need to change. But what we do need to do is draw it. So this is the main function of this class, where we take first we create instant static mesh components. So there's a number of different types of static meshes that you can do. You can have components, you can have static meshes, you can have instant static meshes, you can have hierarchical instance static meshes, and so on. The benefit of using an instant static mesh is if you have the same mesh that you need to reuse multiple times, if you use this, it's much more performant as opposed to creating the same mesh over and over again. Unreal has some optimizations for re-rendering the same mesh multiple times. So it basically cuts down, I think, on draw calls or something like that. But it's nice because we can just create the base set of meshes and materials that we want, and then iterate over our 2D array, and then determine which one we want to add. Think of it almost like a container where we just add instances to it. So that's pretty much how that works. Other information we need before we can set up is the bounding box, so the size of the walls of the floors. Right now it's the same cube that I'm reusing everywhere, but if I did want to change this, this would be important because we need to use that to calculate where we're going to place these in the world as we're generating it. So once again, we iterate over the height and the width. Oh, and also we need to know where in the location of the world we are. So we get the transform and then the location of the X, Y, Z. And this is important because as we are iterating over these rows and columns, we need to check the tile. So again, we check what type it is, if it's a wall or whatever. And then we determine where, based on our column and row, where in the world we actually need to place ourselves. So it's really nice and clean way of creating these transforms by just adding it or multiplying it by the size of it, as well as adding it to where in the world it should be. So we just create these. For the wall, I had to do 2 instances. I have to do one on the ground level and then one on top of it. So it makes it easy to see once I demonstrate. Everything else is almost exactly the same. I only have to worry about the X and Y coordinates. The other thing I had to do was set custom data values. So if you remember when I was in Phaser, I needed to set the X and Y, so when you clicked on something I would know which tile you were on. This lets me do that using these custom data for that particular instance by getting the element instance index. So it'll know that if inside of this instance static mesh component, this particular element inside of the, let's just call it an array, has this value of X and Y. So that helps there. Yeah, creating tile instances is pretty straightforward. We just create new objects. You have to use new object to not create default sub-object because we're not in a constructor. So this is in a, when you're dynamically generating components or actors, you need to use new object, not create default sub-object. So other than that, we just set up the meshes, materials, mobility. It's static, it's not going to move. We register it, we attach it to the root component. So the root component of the actor is the root component, and then everything below that or above that, or child would be below. Below that would be where we're attaching our instance static meshes and all of its components or all of its instances. So yeah, that works. I'm happy. Everything else is, again, pretty straightforward, copied over from Go, getting tiles, checking tiles. This took a little bit of work. I had to clean up the instance components because when you drop it into the editor, it was like recreating my elements. So I was getting these weird artifacts when I looked at the rendered image because I had like 60 of the same instances just on top of each other and fighting for a Z index and all that other nasty stuff. But yeah, so always clean up your stuff. And that is how that works. Now let's take a look at how it looks. We are going to close this, open that, make it bigger. So we have in our side, which you probably can't read, not characters, levels. Inside of levels, we have our battleground map. Sure, let's save that, I don't care. And this is pretty much what it looks like. So we have, although these are just placeholders, I haven't actually spawned these properly. That's right what I'm working on now, which if we have time, I'll start to cover. But yeah, this is what the level looks like. So these right here are the, so if you look at this, when I clicked on it, it's all one giant object or actor called the antigrapho level, which I think is clone or copying Greek because I'm copying it from somewhere else. But if you look over here, you probably can't read it very well, but you'll see level generation where I just selected the mesh and then all the materials. This is coming directly from the battle level H. So I had these edit anywhere category level generation. And you see level generation. So what you can do inside of your C++ class, for those who are unfamiliar with Unreal, you can set these U properties and give them categories. If you set the property types, like there's different ones you'd have to look on. There's like edit anywhere, blueprint callable, blueprint read write, blueprint read, etc. But if you assign these U properties to these properties, then you are able to modify a version of it when you create a blueprint. So if we look at our blueprint, construction script is pretty much what you'd expect it to be. It's like a constructor for a C++ class, which just calls draw in our case. So if I can actually demonstrate, if I delete this from the view and I take the level and I just drop it in, it just automatically generates everything for me right there. What's nice about doing it this way is there's two things. One, I'm generating on construction, which means I can bake the lighting. So baking the lighting is super important, because if I couldn't bake the lights, that means every time every shadow would have to be dynamically generated, or at runtime would need to be calculated, which is going to seriously impact performance, as well as probably look like crap on mobile. This is a mobile project, and I've already run into some cases where mobile looks kind of garbagey, and I'll cover the material stuff in a second here. But yeah, so that's obviously very important to have it be able to generate first on construction, and then I can bake my lighting by going like boop, build lighting. And yeah, and I don't have to worry about runtime performance hits. So I probably shouldn't have clicked that, because now it's going to take like 5 minutes. Or not. Okay, that was much faster than usual. Cool. So if you remember earlier, this is the I need to name that component. This is the root component. You can see I have my static instance mesh for floors, stealth, unwalkables, etc. Going back to our level. Also, I want to set this level to be, oh, it is at location 000. Cool. So that's important for my lights. I think I disabled shadows only because it looked weird in this type of sci-fi Tron-y system to have shadows, because you're like, where's the light coming from? But I still needed kind of like almost a global illumination, so that's why I have the light. I have the lux set kind of low, but I think I disabled, you again can't read this, but yeah, cast static shadows is unchecked and cast dynamic shadows is unchecked. So we got lighting, but we don't have shadows, which is fine. I don't really want shadows unless I create some like huge star above you or something. But so that's what the level looks like. Where did my dudes go? Oh, they're there. Cool. So those are my guys. Also, one other thing that I kind of played around with was getting them to bounce a little bit. So just hit play here, and you can see that they move up and down. It's a little bit slow. I might change the speed, but that's also something that I can change here. Like, what happens if I set that really high? All right, so it just goes kind of weird. And it goes down. So that's not just the speed, that's also the kind of distance. And the reason for that is because I'm using a sine wave, or sine wave. So yeah, I just made it a larger frequency or larger wavelength. So that's why it goes up higher and lower. What else? Actually, the characters themselves, I did create a base character, but I'm going to change this quite a bit. So these are using the old model under characters, blueprints. So these are what the characters are going to look like in game, but I'm actually going to change the way I'm doing this because I don't want to do this manually, and these are all done manually, and I got through all of them and I'm like, why am I doing this? I should have an actor just spawn all the characters with their data, because I have data asset or CSV files with all the data I need. So I'll cover what I'm going to do, and that's what I'm working on right now. But yeah, what else should I cover? Oh, I should probably cover how that bounce worked. Let's look at the bounce. Oh, and then I'll do materials. All right, so bounce first, then materials. So the bounce, basically on tick, so every frame render, we get the delta time, we add it to an accumulator, we then call the sin on the accumulated value. This doesn't need to be there, but whatever. Multiply it by the speed, or basically the length or whatever. Get the current actor's location, get the same one, but then add to the z index, so up and down. this result of the sine wave multiplied by speed or wavelength or whatever. And then we clamp it to make sure it doesn't go any higher than our max bounce heights. And then we do a linear interpolation between the current location and the to location. The idea being that the sine wave will go up and down. So if we get negative values, it'll start to bring it back down and then back up and then back down. And then we just call set actor location, and it does all the magic of re-rendering it for us on the next rendering pass. So that's how you get characters to bounce up and down. Cool. Yeah. So materials and why. So this looks kind of good now, but I do want to show. It's kind of hard to show now. Okay, you know what I'm going to do? I'm going to make this a little bigger. Let's take a look at materials. Not in character. Sorry. So this is a material that I made using a tutorial that I found, which was nice. Where am I going? Glow. So this is the glow effect. And if we look at it, you can see the nice little edges here. And I'm going to disable my distance check so you can see what happens when it looks like crap. So let's kill this and plug in the sharpness directly into the base. So it doesn't look like anything changed, right? Everything looks pretty much the same. So if we save this, it's going to re-render everything. You're going to see some nasty jagged lines. So you can see, I mean, it's funny, the closer I get, the better it looks. But you can see, I can't point at it either. In this area over here that I'm pointing to with my cursor, you can just see little dots every once in a while. And if I change the angle of the view, it looks better. And then if I change it back, it looks worse. And yeah, so I was like, that's not good. That looks terrible. So I couldn't figure out what I needed to change. I made the glow bigger or more. What is it? Sharpness. Was it sharpness? Yeah, I guess it was sharpness because that's what I modified. So if you make the sharpness higher, or sorry, lower. Yeah, it makes more of a glow. So it starts so you can actually see it on being rendered in real time over here too. Crap, what was that? That was at 30, I think. So if I do that and I go away, then it's not as bad. So you're like, okay, that's doable, I guess. So let's set this back to 30. But yeah, like this looks like kind of garbagey. So I talked to my friend who's an actual game designer, and he knows something about materials, so he gave me the idea of, why don't you calculate the distance from the camera and make it glow more? And I was like, that is the smartest idea ever. But apparently this is common knowledge about people who do this stuff. I didn't know it. So what this does is we take the world position and then the camera position. So the distance, we calculate the distance between those two, divide it by some number. In my case, I just did 50 because that's what it looked like. It's just a lot of tweaking. And then you subtract it from the value. So the lower the sharpness, the more glow it has. Make sure it's absolute, and then clamp it between 10 and 30. So it can't go below 10, it can't go over 30. What this ends up doing is, depending on your world position, it'll make it glow more, and if it glows more, it looks better from further away. So when we save this, you're going to see this top edge here. It's probably going to look a little bit better than it was. Maybe not. Okay, it does. So while it looks a little bit better now, what I'm thinking of doing is to not have it just on distance, but actually angle. Because the angle is when it starts to get really gross. So it would be distance, and then maybe somehow calculate the, can you do like, yeah, if you could do camera position and world position, you should be able to calculate the angle of those two from your camera viewpoint. I think. I don't know. All this material stuff is new to me. Oh, and I should totally zoom in because it's probably not very clear. All right, this is as much as I can zoom in. So yeah, that's that. The material itself is really cool. You just take a texture coordinate, in this case it's just 1 and 1, mask it so you're pulling out one layer and then one over here, and then you're using sine wave, and then you're subtracting it or reversing it basically, and you can kind of see what's happening here. It's like it's really bright in the center and it's really dark in the center now, and then you're doing the same thing for the horizontal, so you have the vertical and the horizontal, and then you do some subtraction, some lerps between the two, multiplying it by whatever color you want, and then as well as the glow, so how emissive you want it to be, and then you pop that into the emissive color, and that's pretty much how this material works. And it's really smart, and I like it. Yeah, so that's the short rundown of how this material works and how I got it to look somewhat better during rendering. Yeah, it still looks kind of crappy with the angle. I really got to fix that. That's definitely got to be something I want to work on. But yeah, I don't even know if this is the style I'm going to go for. I just went for it because it looks kind of cool and it's super easy to do. Like, I don't need to sit in Photoshop and generate textures all day long. I can just knock out a material and move on and play with the gameplay. So, but not feel bad about it when I'm playing it. So the other ones are just copies of it, which basically just lets me play with the parameters. So if I just want to change the color, again, I can just modify it there and then move on. So nothing crazy there. Meshes. The mesh I just created in, one thing that was kind of a pain, I created it in Blender, which is basically the poor man's 3D modeling software. But for the UV, it took me a while to figure out the UV map for this, to get it to actually I can show you what the UV map looks like. If we go to UVs, you can just see it's one big square, or it's tiled like this. So basically UV maps are just unwrapping the texture, or unwrapping the mesh, so that you can texture it. So each one of these represents one of the sides of it. So yeah. But it took me a while to figure out, to get it to look right, and literally the only way I figured it out is by going through every single option and going through UV mapping and just trying everything. And the only one that I got to work was like cube projection, and then everything worked. Everything else had, like, it was missing a side, or yeah, it was all weird. But what I did find when I was working on this is there's a really nice plugin called Send to Unreal, which means you can just go to like pipeline export, and then it'll just send it to my project, which is awesome because it saves so much time, because usually you have to go to File, select the object, export, set the settings for the FBX, set the Z index to being up, and all this other stuff. It took 40-50 seconds, but if you're doing that 100 times a day, it gets really slow. So yeah, now I have this nice little pipeline thing. Don't save. Oh, but fun fact, you enable remote Python execution in Unreal when you do this, so I'm sure I could, yeah. Security-wise, probably not great, but whatever. Yeah, that's that. So we have our cubes, we have our map generated. What else did I do? I mean, that was a lot. Yeah, I think the next aspect here, data tables. So as you may remember, I was using CSV files for creating my characters, and now I have it. I really wish I could zoom in. It's so slow. Magnifier. Let's just do it. I'll survive. So data tables, we can literally just drop in a CSV file and create a struct, and then it'll just map everything for us. So it's got all this stuff mapped, and what's nice is you can map arrays, so T arrays, so I'll be able to map everything that I need in here, as well as enums, slot types, conditions, all that stuff I'm going to need. So that's that. Where'd my magnifier go? And then you can see that the struct data is here. So let's take a look at the code. So characters. Let's just look at character data. So character data, We have an enum type of damage, tank, or support. We have our columns, column information here. That's at first it was not working, and I was like, what's going on? And it turns out because this doesn't work, this notation, and has to be exactly match the property name. So there might be a way to rewrite it using a U property, but I figured in Go and the server, I'm not even reading this information. I'm literally skipping over the data. So I'll just make Unreal happy and make myself happy by keeping it as whatever they want. So now they have that. And I have my mesh references as well as my material references. So if we look at the data, which I just copied over, is this character? Yeah, it's characters. So this is what it looks like now, where we just have our character. Also, I had to add this weird like row for no reason to the beginning, but it's just a copy of the name, and I don't know why, but Unreal made me do it. But yeah, character IDs, all the other information, and then we have references to our meshes as well as our material instances. So if you go to any sort of asset inside of Unreal, you can do right-click, copy reference, and that'll create that string for you, and then you can reuse that using find object in C++ as well as other areas of Unreal. But what's nice is you can chuck it all into this CSV file and then load it up, and if you actually look at the characters, you can see that it has the nice little previews for my broken crystal and broken crystal material. So everything's there. And it's also a nice little, kind of easier to read this way, I've noticed too. It makes it easier for me to realize. I think I might work in here and export it, but we'll see. All right, can you export? Oh, whatever, I can just use Google Sheets. Doesn't matter, whatever. Anyways, so data tables, how do they work? Data tables are pretty straightforward. We have character, ability data. Yeah, I mean, I guess I kind of already covered it because there's really not much else that you need to know about it except for having the struct type and then inherit from the F table row base, and then it'll literally do everything else for you, which is pretty amazing. So with that in mind, you still need to work with the data, which is what I'm doing now. So I have created this character spawner. So what I plan on doing with the character spawner is pretty straightforward. I'm going to have it just spawn characters for me, so I can create these base characters, take all that information from the data table, chuck it into the spawn character method, and it'll generate the entire character for me, as well as put it somewhere in the level. So what I want to do is have this in two places. One in the battle level, because we're going to need it to spawn the characters inside of the opponents as well as your team characters, as well as in the menu. If you remember, I said I was going to have a circle, so I need to create basically a circle and then generate the characters at each location, points of locations within the circumference of that circle. So that's kind of where I'm at right now. As for reading the data table, it's a little bit more complex. So we have these constructor helpers, and as I mentioned before, F object finder, where you set the type that you want, and then you again use that reference string, and then you make sure that it exceeded. It was actually able to succeeded to. It was able to find it. And then one thing I didn't really understand is it's returning pointer. Get all rows wants a T array of pointers, but I can't set a T array of pointers in my class properties. So everything that I found was like, oh, you just create a local version of it with pointers. You grab it because it's more performant for Unreal because it doesn't know what you're going to do with it. So it just gives you a list of pointers. And then if you want to store it in your class, then you just iterate over it and then dereference it and add it to your T array, which is what I'm doing. So I should, if everything's working properly, have both my characters and abilities. And I don't think I need to load all of the individual character data, or excuse me, the ability data, like how much damage, because all that information is captured in the top level abilities, and that's going to have the description text and what it's going to do, which is all the client really needs to know. It doesn't need to know all the details of, yeah, maybe it does. I don't know. We'll find out. But yeah, spawning characters. That's where I'm at now. One thing I don't know exactly is how to create and spawn an actor and set its mesh data and material data on construction. I don't even know if you can. You might have to do it kind of dynamically, like I did with the level generation, where you just use the new object and then assign it to the whatever. But we'll figure it out. My throat is super dry today. Anyways, so I guess character spawner. That's where we're at, because we need character spawning to work for level creation or level spawning. So character spawner. Let's get into some coding, even though I only have like 20 minutes left. So we have our spawn character. We need to make sure a couple of things. One, that we actually have if characters null pointer or abilities. Don't really need abilities, but if it's not set, we get a problem. Do a little defensive programming here. Oh, can it be a null pointer? Because it's a T array. We shall find out. Sometimes I get these lines even though it's totally fine. Whoa, what was that? Oh, okay, yeah. So I guess no, we can't. I guess empty, I guess, would be. Oh, IntelliSense is so slow. I'm gonna have to restart my editor. Yeah, you know what? I'm gonna restart it because it's really slow. And it's been open all day. So, battleometry, yes. Because it's not. Yeah, it's a T array, so pretty sure empty is what we want. Please wait. Okay. Nope. Illegal left hopper has type void. Oh, empty actually empties it. Is empty. Come on, IntelliSense. Is empty. Why are you not? Oh my god. Maybe it needs to build properly. Is empty is not a okay. When all else fails, read the documentation. Whoa, do not need to print. T array is empty. Yeah, what the heck? Come on, Unreal. Bool. Returns true. Do I need to actually include? See the declaration. Of course, the moment I start programming, I already get a weird error. Now it shows up. Whoa, it doesn't have it. In place. Inline void, yep. Add zero, begin, check, contains, copied empty, debug, find. Okay. I guess there isn't. Just gonna do num. we'll do that. Our abilities, none. Unless they're equal to 0. Alright, so we defend ourselves against that being empty, and then I don't need this anymore. You should let them have breading capabilities from Alcantaro. I don't understand what you mean. Do you mean breeding capabilities? Those are they make little babies? We will wait for an answer. Also, I need to turn my notifications on. I didn't hear that. Okay. Character's number, abilities, location, owner, character ID. So we need to look to make sure that the character exists. So for just do an auto f character. Nope, what am I doing? Auto is the type. Character is equal to, oops, not equal. What's it? Characters. Character ID equal character ID break. Also, we need a character data chosen our character respawn. I hate character. So we'll do character. So what happens if it is not selected? It's a struct, but it's not a pointer. I kind of want it to be a pointer. So if not, or just character to respawn, null pointer, return. Should probably also, what is it? Return a bool. Although, I mean, if it's unable to find a character, like, the game's busted, because this should never fail, ever. So, we'll just make sure we don't crash. So, we have our character to spawn. Otherwise, we quit. So, we need, is it spawn actor? How do I do this from, because I don't know where I'm being called from. I also need to actually create the class, because this is just the character data. So, base character. This is where I wish I knew more, because like in the constructor, I want to be able to pass in the, oh god, what is the constructor instantiation format? It's like, actually no, I need to view property, probably doesn't need to be any anywhere. F character data. Data. It's like character. I don't even know if that's possible. My guess is it's gonna, yeah, missing. Plus initializer list. That's what I want. That's what happens when you don't use a programming language for a while. You know what you want to do, but you don't remember how to do it. Struct s class x. Oh, duh! It comes after the constructor. So that would be here, not at the class definition, because that doesn't make any sense. Does it need? Nope. Okay. But how do you do like a empty? And does Unreal even let you do this? Also another good question. Stop yelling at me. Oh. F character, yep, might help if I actually included it. Character data. Should complain that that doesn't make any sense. Yeah. Whoa, that's some interesting messages though. Empty link function for generated, found in what should be a comma separated list. Oh, I think you know what? I'm just gonna do this dynamically until I know what I'm doing more. So I'm just going to have a, what should I call it? Initialize. I know. Nope. I guess I can just do f character data, and that'll be a reference. And I will store. Oh, it's going to do a copy. Don't think you can store a reference. We'll find out when it crashes. Boop. Okay. So now our character spawner will call. Oh, we need to create a new character. So new object base character with, can you pass constructors to Unreal? UE4 new object constructor. Constructing a U object while assigning object members. Category defaults, generated public. Sounds to me you are fighting against the engine instead of just using T subclass of. Okay, this is if you already have it, but I need to dynamically set. Continue or else default value, some value. Yeah, this doesn't actually have a constructor. Just maybe, yeah, maybe just do this and then character to spawn. Let's just see what happens when I create one of these. Base character, new character is equal to new object, this character to spawn. If new, oh, this is really awkward writing with my hands sideways. New character, return. Lots of safety checks. Okay. Let's see if it throws up at me. Probably will. Base character, undeclared identifier, because I did not include it. I kind of have an imports problem here, because base character is importing. Wait a minute, no, do I? Character spawner is importing base character, base character. No, that's importing from character data, so they're separate. Cool. Thought I had an import loop or cycle. Okay. Base character undeclared identifier. Line 64. Wait, what? Character spawner 64. It's a base character because it's an actor, right? Yep. So any object that inherits from an actor is supposed to be prefixed with an A. Anything that inherits from a U object is supposed to be a U. So when it generates these classes for you, it does these things, and sometimes I forget. So that's why that happens. New object, no matching overloaded function found. Didn't think so. Cannot convert from F character data pointer to const U class. Don't know what that means. Also, I just got some weird notification. What was that? I don't know. Yeah. So new object, 3 overloads. Let's take a look at them. Outer class F name. Yeah, so I can't just like pass in arbitrary stuff, which is a bummer. So I don't know if there's another way of doing it other than just like calling, like adding setters and getters. Beats me, man. I imagine I will figure this out. And I will report back on Wednesday or Thursday whenever I stream next. But I'm running out of time here. So, yeah, what else are we going to do? I guess we can't really do anything until we get this character to spawn. So, character data, character spawner. You know what, screw it. I'm just going to see if this works. Just get a new character. References must be initialized. Yeah. Base character. Can't do that anymore. I just make this one thing working, and then I'm gonna quit. Building, potentially initialized local variable. That is bullcrap. No, it's not. It's not bullcrap. Always initialize your variables. Well, at least it compiles. All right, well, I guess next, I will get this whole spawning thing to work, figure out the proper way of doing it with initializing the variables, get the characters in, get the menu to generate the nice circle of the characters that you can select from, and then, yeah, should be good enough to get the match. So the menu will be able to load this level and spawn the characters, and then we can start getting the movement. Oh god, the pathing. I gotta do the pathing. I gotta translate the pathing over to C++ from Go. So that should be fun. I'm sure something will go wrong. But anyways, thank you for watching. Yeah, next week hopefully I'll have, or next Thursday, hopefully I'll have a little bit more done. Until then.